In the following exercises, graph each logarithmic function. So we're going to do 178 here. And this is where I wanted to get to, was the graphing. Because this kind of opens it up for the conceptual understanding of logs and how they actually work with exponentials. And this is kind of a nice thing for us to understand as we move forward, especially in solving and on any other cases that come up. This idea of logs and exponentials and how they play together is actually really nice. So what we're going to do is we're just going to graph this log function first. This is definitely going to give us a deeper understanding. So in order to graph this log function, we should think of XY table. So the first value I'm going to start with is 1/4. So I'm going to go through the process of saying, okay, 1/4. So I'm really looking at the log base 2 of 1/4. And that equals my y. So I'm going to go 2 to the y equals 1/4. And 2 to the y equals 2 to the negative 2. So y equals negative 2. So log base 2 of 1/4 is actually negative 2. Now, as we do a few of these, you're going to see a really nice pattern emerge from this. So the next one I'm going to try is 1/2. So I'm going to take log base 2 of 1/2. And that equals y. So then, that's going to be 2 to the y equals 1/2. And 2 to the y equals 2 to the negative 1. So y equals negative 1. So when I plug in a 1/2 here, that equals negative 1. All right, so next I'm going to try 1. So when I plug in 1, that's log base 2 of 1. And that's going to equal y. So that's 2 to the y equals 1. So y equals 0. And because remember, anything to the 0 power is 1. So my y has to be 0. All right, so now I'm going to try 2. So when trying 2 here, that's going to be log base 2 of 2 equals y. So this is going to be 2 to the y equals 2. And that means my y is going to have to be 1 there because my exponent here is 1. So my y equals 1. So now I'm going to try 4. So that would be log base 2 of 4 equals y. So that would be 2 to the y equals 4. So y equals 2. Hopefully you're seeing this pattern here, and actually even what x values I'm picking. Now what I want to do is I want to move these around a little bit because I want to get more in there. So I'm going to adjust my table. So I switched them all up here and put a few more values in on both the closer to the 0 side and larger than 1 side. So if you notice here, our pattern, this should be a negative 3 and that should be a negative 4, and it will be because 2 to the 4th is actually 16. So to get a 1/16, it would be 2 to the negative 4. So that's how that works out. And hopefully that's okay with just my explanation. If not, work through it and get comfortable with it. And this is going to be 3 here and 4. Because remember, it's going to be 2 to the 3rd, 2 to the 4th. And that's what's going to get me 8 and 16. So this is the design of it here. So now what we're going to do is we're going to graph all this and see what we get. So hopefully we can get this all in there. Because my x's, it goes up to 16. So I think what we're going to do is we're going to go every 2. So I'm going to change this to every 2. And that's on both the x and the y. So that will help us to graph these. Now the more difficult thing is that my x's are like 1/16, 1/8, 1/4. And that's where it's going to kind of bite a little bit for me because it's not, maybe we don't have to go out as far as 16. Or maybe just do a few of those in the graph. Yeah, we'll do that. We'll do a few of these. So we'll just do what we kind of started with. We'll do those ones and just go up to 4. So then we can go every 2 then. Yeah, that's what we'll do. So I'm going to change the scale again. And we're just going to do every 1 is every 2. Yeah, and we're only going to do not all of these, but we're just going to do a handful of these. We'll do this one here, this section. But I did want you to see that pattern. Okay, so we'll do 1/4. All right, so 1/4 is going to be half of a half. So at 1/4, it's -2. So that'll be there. Yep, that'll be right in the middle of that half. Yep. And then the half is going to be -1. And remember, we're doing every 2 here. And then it'll be at 1, it's 0. Okay, and then it'll be at 2, it's 1. And then at 4, it's 2. So there's 1. So that'll be there. So that looks like a pretty good graph so far. So now let me graph this so you can see what it's actually doing. And hopefully you're okay with where I end with this one. It's going to create this vertical asymptote at x equals 0. And that's what this one does here. So one thing I want to show you now is that's the one. Okay, that's the graph you can see there. Now, along with this graph, I want to introduce another. And I want to talk about y equals, let me draw it a little higher. So y equals 2 to the x. And that's what I want us to graph next. And I think the way I'm going to start this is I'm going to start with a -4. So when I have 2 to the -4, that's going to be 1/16. Hopefully you're okay with that. If not, work it out. And then I'm going to do -3. So then -3 is going to be 1/8. And then -2 is going to be 1/4. Because remember, it flips to the bottom and makes the exponent positive. So hopefully that's okay. -1, it's going to be 1/2. And at 0, anything to 0 power is 1. And then at 1, it's going to be 2. And then at 2, it's going to be 4. Then at 3, it's going to be 8. And at 4, it's going to be 16. Now take a look at these two tables side by side. If you notice, both of these tables here, the x and the y's have switched values for all of these. What that tells you here is it tells you that these two functions are inverses of each other. And that's something you may have not known up until now. And that's the reason why the structure of the logs is so different, because it actually takes on the structures of the exponentials. Well, back and forth, of course, just the idea of the powers, and that's where both of these functions kind of live. What we're going to do here is we're going to graph this now. But before I graph, I'm going to put in the y equals x line. Now for the other one, I'm going to graph the same values because I want you to see those exactly and the mapping of those. Now I drew the y equals x line because we know that that's where the inverses map across or reflect across. So that's why I put those in there. So now if I look at the first value there, it's -2, 1/4. And I'm going to put the values in so we can see those clearly, so we don't get any confusion here of what they are. Okay, so there's a handful of them. So it's going to be -2, 1/4. So -2, 1/4. So that'll be right there. And the next one is going to be -1, 1/2. That'll be there. And then it's going to be 0, 1. And then the next one's going to be 1. And then I go up 2. So that's going to be there. And then the last one is going to be 2, and that's going to go up 4. So that'll be there. And if you look at the mapping between these now, that's the same distance, that's the same distance, that's the same distance. Same with that one and same with that one. And we can see across the y equals x line that all those distances are the same. So now when I graph this line, oops, let me do it a little better than that. The precisions will be nice here if I can be somewhat precise. And this means I would have this horizontal asymptote. And think about it this way, we're switching our x's and our y's here. And you can see now how this asymptote here with the log is now this asymptote here for the exponential. So what I'm saying here is when we're dealing with exponentials and logs, they are inverses of each other. And that's a really powerful thing for us to have here. Now the reason why I say that is because now we can actually, like when we had x squared equals 4, we square rooted because the square root of x was the inverse of x squared, so those would cancel out. And now that means we can solve more types of problems because of these inverses and inverse relationship they have. So now notice this. The first one I graphed was y equals log base 2 of x. So how we tell that they're inverses is because the bases are the same. So now take a look at this one now. What about the y equals the ln of x and y equals e to the x? Now remember, ln of x is really log base e of x. Oops. So that tells me, notice those bases are the same, just like the 2 in both of those equations there. So that tells me then that ln of x and e to the x are inverses of each other. Ooh, you may have not seen that one coming. But those are ideas to consider when we're going through these. Now, if I have an ln function now, and I want to get to the inside of that because there's an x in there, I can just take those to the e. So then because e is the inverse of the ln of x. So those are the ideas we see, and this type of graphing here really opens that up for all that. So knowing that we have inverses. So now if I take a look at number 179 here, the inverse of log base 4 of x is y equals 4 to the x, the exponential. Okay, so keep that in mind as we're going through these with the equations and everything here. So, nice video.